Again, welcome to Java Programming Language, CS 102 at Rages University. In this lectures, we're going to cover chapter 4 of our course textbook, which is Java Mathematical Functions using Java Math class. So the motivation behind these lectures is that suppose we need to calculate the area enclosed by 4 cities, given the GPS locations, that's the latitude and also the longitude values. So here we have a diagram here, 4 cities. Each city we have 2 points, that's their GPS location, the latitude and also the longitude values. How can we solve this problem? By using Java language. We know in mathematics we have some formulas. For example, the formula may consist of trigonometry functions. The good news is that Java gave us the math class. So with the math class, we can be able to find any trigonometry value in any formula. So our main objective is to solve mathematics problems by using the Java built-in methods in the math class. So in Java, the mathematical functions, normally we use it to perform a mathematical operations. So Java provides us many useful mathematical or methods in a math class for performing common mathematical functions. So the math class have 3 sections or 3 parts. The first one is the class constant. So we know in mathematics, pi here stands for pi. The pi is a constant value, which is again 3.142. We also have the exponential value. The exponential value normally is 2.718, etc. So in Java, we use the uppercase pi to represent pi value, and also uppercase e to represent exponential value. And the next will be the class methods. In Java, we have the trigonometry methods. We also have the exponent methods. We also have the rounding methods, the mean, mass, absolute, and random methods. So we shall go through each of these. So first we start with the trigonometry method. Example, here we have the sine. The sine will take only one value. The argument data type is double and a. A can be any value, but the values have to be, again, in radians. So if the values is in degree, we can use 2 radians method to convert it. Again, we're going to see an example. So cosine, tan, arc cosine, arc sine. Arc sine means A-S-I-N, arc cosine. We know in trigonometry, arc is A-R-C, cosine. In the Java trigonometry method is A cos, means arc cosine, arc tan. One thing we should remember is that the argument value always should be in radians. So if it's given in degrees, we convert it to radians. So here we have example for math. Anytime we are using the method, we have to start with the class name. So math.sil, which is our sine method. It's the same thing with the system.out.println. We are using the method println, but we also have to include the class name, which is the system, etc. So we also have a second example, math.sine, math.pi. Again, this is 3.142. The value should be in radians. So it's 3.142 divided by 6, and that will return 0.5. So pi can be degrees. A pi degree is 180 degree. When you convert 180 degree to radians, it's 3.142. Also, we have a sine, pi divided by 2. The answer will be 1, because we know sine 90 degree is 1. Cosine 0 is 1, and cosine 90 is 0. So cosine math.pi divided by 2 is 0. And also, as we said, if the degrees, if the values is in degrees, we can convert it to radians by using the method to radian. In order to use the method, also we have to have the math. So math.to radians 90, and the answer will be 1. Next, we go to the exponent methods. We have the exponent lowercase exp. It takes one argument, whatever the value is. So always exponential value is an exponent value. So let's say e raised to the power 3, which will be exponent, the argument will be 3 or 3.0 since it's double. So exponent double A means it will return the value of e raised to the power of a. Then we have the log. The log method is the natural log, so it will return the natural log value of a. Then we have log 10, which is the log base 10. So this will return the log base 10 value of a. Then we also have the power. The power method, which is POW, always takes 2 arguments because the first value will be the base and the second value will be the exponent. So power AB will return a raised to the power of b. Then the square root of a will give us the value of the square root of a. Now let's see some examples. So here we have a math again, as we said, anytime using any method, built-in method, we have to start with the class name. So here we have the math dot exponent 1, which means e raised to the power 1, which is 2.71. Then math dot log 2.71 will return 1. Then the power 3 means 2 to the power 3, so that's 8. And also power 2 means 3 to the power 2, so that's 9. And also the power argument can be double, 3.5 raised to the power 2.5 will give us 22.91765. We also have the math square root of 4. The square root of 4 is 2. And the square root of 10.5 is 3.24. So now let's go to the rounding methods. So first we have the cell method. It returns double and it takes the argument x double. So a cell means we are going to round the value up. So s rounded up to the nearest integer. What this means is that, for example, if we have 4.01, the answer will be 5 because it's rounded up. If I have 4.999, the answer will be 5. 4.0, the answer will be 4. But 4.0001, the answer will be 5, rounded up. We also have the floor. The floor method will round it down to its nearest integer. So if I have 4.999, the answer will be 4. It doesn't go to 5. It rounds it down to its nearest integer. We also have the rent. Rent also rounded it to its nearest integer. So here we say if s is equally close to 2 integers, the even one is returned as a double. And also we have the round method. The round method works the same way as our mathematics. For example, if we know in mathematics, if our decimal value is 0.5 or higher, we approximate it to the nearest one more value. So for example, if I have 4.6, we approximate it to 5. If I have 4.2, we approximate it to 2. If the decimal value is 0.5 or higher, we add 1 to the whole number. If it's less than 0.5, we ignore the decimal value. That's the concept here. Here we have a math.for s plus 0.5. This 0.5 makes the difference of rounding it. If it's 0.5 or higher, we add 1 more value. If it's lesser, because we are going to convert it to int. So let's say, for example, we have 4.2. 4.2 plus 0.5 will give me 4.7. 4.7 int will be 4 because it's only 4.2. So the decimal is gone. Now let's say we have 4.5. 4.5 plus 0.5 will give me 5.0. The int of 5.0 will give me 5. The same thing if I have 4.7. 4.7 plus 0.5 will give me 5.2. The int of 5.2 will give me 5. So this, again, the round works the same way as mathematics. If the decimal value is 0.5 or more, we add 1 to the whole number. If it's less than 0.5, we ignore the decimal value. But always we should put the whole number int or long. If the value is very big, long. So we get only whole number returns. So let's see some example here. So you can see that with the cell, we return type will still be double. But when we look at the round returning value always will be int because we have the int to convert it to int. When you are running a value means you don't want the decimal part no more. So cell 2.1 will give me 3.0 because we will round it up, so 3.0. Now cell 2.0 is same 2.0. There's no any 0, 0. Negative 2.0 also is the same negative 2.0. But negative 2.1 will give me negative 2 because it's rounded up. Negative 2 is bigger than negative 2.1. Now 4 will round it down. So 2.1 will give me 2.0. And 2.0 is the same 2.0. But negative 2.0 also 0, 0, so negative 2.0. Negative 2.1, we are rounded it down. So if the answer is negative 2 is bigger than negative 2.1. So the answer will be negative 3. Negative 3.0 is less than negative 2.1. So the range also, the same concept, 2.1 will give us 2.0, 2.0 give us 2.0, negative 2.0 also give us negative 2.0. But negative 2.1 also will give us negative 2.0. And 2.5 will give us 2.0. So we are ignoring the decimal places. But if we have a rounded 2.6, that would be 3 because 2.6 plus 0.5 will give me 3.1 and it's converted to int. Now 2.0 will give me the same 2, negative 2.0 will give me this negative 2, but negative 2.6 will give me negative 3. Here we are not rounding it up or down, we are approximating it. So negative 2.6 plus 0.5 will give me 0.1, 1.1, and that will give me negative 3.1. We change it to int, then we get negative 3. So that's the concept here again, one more time. In the run section, we can see that again, we round it. We use the math.floor, then s plus 0.5. That's what it returns. The run again, the same thing with double. Long means again, the values were bigger, but both will give us an odd number. So run float x means do your floor, add 0.5 to it, then convert it to int. So that's the example. So the next one will be the mean, mass, and absolute value. Minimum at least takes 2 arguments because if you take only 1 argument, then the answer is the same. Minimum and maximum will return the maximum value among 2 or more values. So mass A and B, the one that is bigger will return it. Mean A and B, the one that is smaller, minimum will return it. Absolute value means always the answer is positive. So let's see an example. Also, the last one is the random. Random number will always return a random value generated between 0.0 to 1.0, excluding 1.0. So this means 0.0 to 0.9 if it's 1 decimal place, which mostly 1 decimal place. So let's see some example here. So we are using the mass. Again, we start with the math class first, dot mass 2.3. So it will return 3. Math.mass 2.5 and 3, still return 3. Now math.mean 2.5 and 3.6, it will return 2.5. That's the minimum. Then absolute value, negative 2, will return positive 2. Negative 2.1 will still return positive 2.1. The next is the random method. As we said, the random method normally generates values randomly between 0 to 1, but excluding 1, so 0 to 0.9. So example is given here. Now, if I want to generate numbers between 0 to 9, then I will multiply by 10. because random by itself, it will generate a number between. So if I call this mat.random, this will give me values between 0 to less than 1, up to 0.9. So if I want to generate a whole number from 0 to 9, then I'll multiply by 10, and I'll convert it to int, since the value will be in decimal place. So this will give us 0 to 9. Now, if I want to generate numbers between 50 to 99, see the first number is 50. And we know the random method always generates the first value is 0. So this means we had 50 to it. So the first number generated 0, we had 0 plus 50 will give me 50. Then the rest will continue. So we get 50, 51, etc. all the way. Now, excluding the number is, so the last value will, in this case, will give us 99. It won't go up to 100. And this is the formula to use, the concept here. If I want to generate a number between A to A plus 5, excluding A plus B, A plus B. So I generate number, let's say, from 10 to 19. So in this case, I will have 10. Then B will give me 20. I'm going to, if it's A plus B. So for example, here you can see our A plus B here is 50 plus 50 is 100, but we go up to 99. So if I have A to be 10 and B, let's say B also 10, then I'm going to generate from 10 to 19 because A plus B is 10 plus 10. Same apply if I want to generate a number, let's say from 20 to 80. 20 to 80 means if I had two numbers, I will start from 20. The second value is 80. So it will be 20 plus 60. So B will be 60. But in this case, I'm going to generate a number from 20 to 79, excluding the 80. That's the formula here for it. So now we went through most of the math classes. Again, the constant, the rounding, the trigonometry, and some other maximum, minimum. So now let's see some example here. So here we have a case studies here. A triangle is given to us. We know the S1, the point values, which will be the latitude and the longitude values. S1, Y1, S3, Y3, S2, Y2. And the question said we should find the side ABC, which are lowercase ABC, and also the uppercase, the angles ABC. We can use the formula here. Again, this is trigonometry. To find angle ABC, these are the formulas: arc cosine, A squared minus B squared minus C squared divided by minus 2BC for A. Angle B, arc cosine, B squared minus A squared minus C squared divided by minus 2AC. And then angle C, arc cosine, C squared minus B squared minus A squared divided by minus 2AC. Now, in order to find the angle ABC, it means we have to find the side ABC, because the side ABC is not given. They only give us the points. Again, the latitude and the longitude. So this is the program we are going to see. So here they say, write a program that prompts the user to enter the X and Y coordinates of the three corner points here in the triangle, then display the triangle's angles. And this is the code. So again, since we are going to ask the user to enter the 6 values, the coordinates, 3 points, each point has X and Y coordinates, so 6 values. We import our scanner class and create a scanner object named input. And we use it to enter all the 6 values. Now we are done. We know the formulas. Let's convert the trigonometry formulas to Java. So to find the side A, it will be the square root. So we use the math.square root method. S2 minus S3 times S2 minus S3. which is S2 minus S3 square, plus Y2 minus Y3 all square also. Then to find the side B, it will be mat dot square root S1 minus S3 times S1 minus S3, which means they are square, plus Y1 minus Y3 times Y1 minus Y3. To find the side C, is mat dot square root S1 minus S2 times S1 minus S2 plus Y1 minus Y2 times Y1 minus Y2. So now we know the three sides, A, B, C. So we can be able to find the three angles. So to find angle A, again, we have this formula given to us. As we said, all the trigonometry functions in the math class, the argument should be radians. So that's why here and our answer, of course, will be in degrees. So that's why here we are using 2-degree method, because the answer we get will be radians, because all the trigonometry function takes the argument data type is in radians. So here we just convert the formula. This formula is given to us already. Arc cosine A square minus B square minus C square divided by minus 2BC. That will give us the angle A. So to write it in Java, again, we need a class mat.2degree. We want our answer to be in degrees. Then we have the mat.arc cosine. So mat.a cos A square minus B square minus C square divided by minus 2BC. Then to find the angle B, the same thing, we have to convert our answer to degrees. We have the mat.a cos B square minus A square minus C square divided by minus 2AC. And angle C also the same thing. We convert our answer to degrees. And the formula is A cos or arc cos C square minus B square minus A square divided by minus 2AB. So we have the angles now, ABC, and here we came and displayed the result. Here also we are rounding the answer. So remember, rounding the answer will give us an nth value. So whatever degree we get, we multiply by 100 and divide it by 100.0 to round it up. So let's see next example. The next example is geometry again, to find the area of a pentagon. So here they say we should write a program that prompts the user to enter the length from the center of the pentagon. And we can see now, so we are going to enter the value of R. That's the length from the center of the pentagon to the vertex. The vertex are the points, the point sections. And they are the same value from the center, since all the sides are the same also. We know a pentagon, excuse me, a pentagon normally have 5 sides and all the sides are the same. So we are going to ask the user to enter the R value. Then the question said, after that, we are going to find the area of the pentagon, as shown here. Now they give us the formula. So the formula for computing the area of a pentagon is area equal to 5 times the side square divided by 4 times the tan pi over 2 over 5 pi divided by 5. So here we don't know the S value, we only know the R value. And in the question, they said to find the side, the formula is S equal to 2R sine pi over 5. S equal to 2R sine pi over 5. So this tells us that first thing we need to do, and we need to still import the scanner class, because we are going to ask the user to enter the R value. After the user enter the R value, we are going to find the S value first. When we get the S value, then we can find the area. So that's like 3 steps. Let's go. So again, we import our scanner class. Then our main class name is exercise 4 under scope 1. We need our main method. In this course, again, we are going to only write Java standalone application. So we need a main method. So we create our scanner object named input. Then we ask the user to enter the length from the center of the pentagon to the vertex. So it's R. The variable name will be R. Input.next double. When the user enters the R finish, we can find the side. So the side will be 2 times R times mat.sin. And it's power divided by 5. So we use the mat.pi divided by 5. We may also divide and decided to use 3.142 divided by 5. That's fine. So after we get the value of the side, we can find the area now. So the area is 5 times the side square. So side times side divided by 4 times mat.tan, mat.pi divided by 5. So when we get the answer for the area, we can print our result. So the area of the pentagon is mat.run. We run the area value also. So we multiply by 100 and divided by 100.0. So let's try the next example here. So here we have a question about finding the distance of an object. And we say the great circle distance is the distance between 2 points on the surface of a sphere. So let S1, Y1, and also S2, Y2 be the geographical latitude and longitude of the 2 points. So our 2 points will be S1, Y1, S2, Y2. And in the question, they gave us the formula. So to find the great circle distance between the 2 points, this can be computed using the following formula. D, which is the distance, equal to radius times arc cosine, sine S1 plus sine S2 plus cosine S1 plus times cosine S2 times cosine Y1 minus Y2. So again, the formula is given to us. Radius times arc cosine, the sine S1 times sine S2 plus cos S1 times cos S2 times cos Y1 plus Y2. So in this program, what we need is to ask the user to enter the 2 points. When the user enters the 2 points, we can find the distance between those 2 points. So here they say we should write a program that prompts the user to enter the latitude and the longitude of the 2 points on the earth in degrees and displays great circle distance. Now the radius is given to us. The average radius of the earth is 6,371.01 kilometers. And we should note that we need to convert the degrees into radians because the input we ask the user is to be in degrees, but sine, cosine, or in general, trigonometry functions, the argument in Java is always in radians. So we need to convert, so use the mat dot to radians method, since Java trigonometry methods use radians. So this will be the result. Again, we are going to ask the user to enter the points. So we import our scanner class. We have our main class name with a curly brace, the main method with a curly brace. First thing we do is to create a scanner object named input. Then we ask the user to enter the first point coordinates, which is latitude and the longitude. So the user enters S1 and Y1. Then we ask the user to enter the second point coordinates or the latitude and longitude. And after we have the 2 points, then we know the average is a constant value, which is 6371.01. So we can find the distance. Distance will give us 6371.01 times the mat.acos, mat.sin. Remember again, our answer is in degrees. So we convert it to radius. That's the input, S1, the value to radius, before we find the sine of it. Again, the input the user enter is in degrees. So we use the method to radians to convert it. And the same thing we do to the mat.sin, mat dot to radians, S2, X1, The same thing for S2 here, the same thing for Y1 and also Y2. So the format is given in the question. Our goal is to write it in Java. Then after we find the distance, again, we can display our results. So the distance between the 2 points is the D value. So this will be the conclusion of our lectures in using Java mathematics class. So again, in our next lectures, we're going to learn the Java built-in class for character and also the strings. So wish everybody the best. Thank you for your time.